Okay, so we're going to talk about functions a little bit. I think one of the best ways to talk about functions is looking at a graph. So we're going to do just a simple line, f of x equals x plus 2. And you can, if you want to, you can think y equals x plus 2 if you want. Okay, so when you graph a line, we're going to do the t-chart. We're going to have x, and then we're going to have y equals x plus 2. So we're going to do -2, -1, 0, 1, and 2. And we're going to plug in this -2 for this x. So this becomes -2 plus 2, which is 0. This becomes, now this x is -1, so you got -1 plus 2 equals 1. And then here you've got 0 plus 2 equals 2, 1 plus 2 equals 3, and 2 plus 2 equals 4. And if you notice, these all go up by 1, okay? So we plot. So -2, 0 is right there. Okay, -1, +1 is right there. 0, 2 is right there. 1, 3 is right there. Notice how they're all going up 1, 2, 4 is right there. Okay, so that's our line. And why is that a function? That is a function because all of our x values are unique and they correspond to exactly one y value. Okay, so f of x, the y, is a function of what x is a function of x. Okay, so you need your x in order to find your y. Okay, so that's an example of a function. The other reason, and we're going to talk about this, is it passes the vertical line test. So functions pass the vertical line test, or VLT. Okay, what that says is that if you make a vertical line anywhere along the graph, it will pass through the graph only one time. Okay, so a counter example would be this graph. Okay, so that's a graph. It is a graph. It's represented by an equation, but it's not a function. Okay, not a and you can tell just by looking at it that that vertical line is going to go through twice. Okay, so that makes it not a function. Okay, now one of the things that confuses some people, your x has to be unique, but not necessarily your y. And the example I like to use is the parabola that opens up or down. So for when you have a parabola, and we can, if we want to, we can go ahead and graph a few points, right? So, whoops, I meant to make the t-chart. So if we have f of x equals x squared, let's erase that so we don't get confused. So we can think y equals x squared. Okay, so we have our x, and then we have x squared, y equals x squared. So if x is -2, -1, 0, 1, 2. Notice how we just kind of put in whatever x. We're going to hang out around the origin a little bit. So when we square x, we're always going to get a positive, right? Even if x is negative, a negative times a negative is a positive. So that's going to be 4. That's going to be 1, 0, 1, 4. Notice that we have a couple of y values that are the same, right? And that will actually be true if we extended these x values out to negative 3, positive 3, you're going to get a 9, negative 4, positive 4, you're going to get a 16, okay? So you start at 0, 0, right there, okay? And then you have negative 1, 1, and positive 1, 1. You have negative 2, 4, positive 2, 4. And if you notice, I'm getting this nice symmetrical graph around the y-axis, right? This is your y-axis. It's your x. And this is a function because it passes the vertical line test. Vertical line test states if the vertical line goes through only one time. Now if we extended this up and up, it's still always going to go through once. So this is a function. Okay, y equals x squared, or f of x equals x squared. All right. And the weird thing about that is if you were to anyway, I was going to say that you can have the same y. The other good example, and it still be a function, the other good example is the sine curve, the sine wave. And I'm not going to write a t-chart for the sine wave. I'm just going to talk about it for a second. So this is a sine wave, right? Now if you look at this curve for a second, you realize that all the x's are going to be unique, but each y value gets repeated an infinite number of times. Okay, so this happens to be 1 and negative 1 on the sine wave. Okay, or even like this y right here keeps getting repeated. Okay, a million times. Infinite number if it keeps going on and on and on. But your x is different. And that's what's important with a function. And then also this passes the vertical line test as well. Okay, I hope that helps a little bit. Okay, thanks, bye.